Hello my dear students, so how are you all? I hope you all are doing well. I am Bhagwanti K. Patel, your dedicated chemistry faculty committed to guide you and prepare you for CET examination. So today we will be discussing about our first chapter, that is some basic concept of chemistry, which will be a base for the whole physical chemistry concepts and all the chapters throughout the sessions. So now mole concept is divided into 5 basic sub-concepts which you have to learn. So the first concept is units and measurement. The second concept will be your laws of chemical combination. And the third concept is mole and mass. And next is your empirical and molecular formula. And the last one will be your stoichiometry and stoichiometric calculation. In case of units and measurement, you will be studying about SI units and its conversions. Laws of chemical combinations, there are a number of laws which you will be studying one by one. And next is your mole and mass concept, in which you will be defining what is mole and different kind of masses. Empirical and molecular formula, which is very important to for your problem based question. You can expect problem based question based on this topic. Next is stoichiometry and stoichiometric calculation, where you will be studying limiting reagent, POAC method, concentration term, dilution and neutralization. So let us start today's session without any further wait. So first concept was our units and measurements. So in case of standard units, these are the units which you must understand, and what are the SI units you have to know. So first let us see. First physical quantity is length. Length is symbol is small l. And the next quantity is mass, and the symbol of this quantity is small m. And next is your time. So times symbol of the quantity is T. Electric current, and the symbol of this quantity is I. Temperature, the symbol is capital T. Amount of substance N. Luminous intensity IV. So see here, symbol of quantity is different from your SI unit. Symbol of quantity will be used when you are writing your formulae. Okay, and the name of unit comes to length. It is your meter, and the symbol will be small m. Mass, kilogram. Symbol will be kg. Time, seconds. So it will be SEC, somewhere it is presented, or simply S you can write. Electric current, I, ampere. A. Temperature, it is usually present in Kelvin scale. So K. Amount of substance, mole. It will be written as MOL. Luminous intensity, candela. CD. So these are the physical quantities you must know. It is very easy, I guess. So next is how this physical quantity will be associated with this powers, multiples of 10, you can say. Okay. So see, if there is given in the question, that is picometer. What does that mean actually? Picometer means 10 raised to minus 12 meter. Understood? So whenever you have 10 picometer, it is simply means 10 into 10 raised to minus 12 meters. Understood? So in examination, you might expect to convert these symbols, which are multiples, into formula, and then you have to solve your problems. So see here, tera means 10 raised to 12 plus 12. Giga means 10 raised to 9. It is giga. And nano, it is 10 raised to minus 9. Mega, 10 raised to 6. Micro, 10 raised to minus 6. Kilo, 10 raised to 3. Milli, 10 raised to minus 3. Hecto, 10 raised to 2. Centi, 10 raised to minus 2. Deca, 10 raised to 1. Deci, 10 to the power of minus 1. And another most important, 10 raised to minus 10 is written as Armstrong unit. Understood? So that will be very important for you, and in most cases it will be asked in atomic structure chapter. Now let us move further, that is important conversions. These conversions are very important with respect to your chemistry. Okay, so the first one is temperature. So to express the temperature, we have 3 units. SI unit is Kelvin, but other 2 units are degree Celsius and Fahrenheit. So if degree Celsius is given, how you will convert it into Kelvin? So simply given value of degree Celsius and you will add with 273. Understood? And if you have to convert it into degree Fahrenheit, simply you will divide 9 divided by 5 degree Celsius plus 32. Next, when it comes to the pressure, you might expect to convert it into 1 atmosphere to 1 bar. So it will be 1.013 bar. If not in bar, mm of Hg you can expect, that is 760 mm of Hg. Otherwise, it is also called as 760 Thor. It is equal to 1.013 into 10 raised to 5 Pascal. And another one important, that is your 1 bar will be equal to 10 to the power of 5 Pascal. When I come to volume, you might expect 1 liter is equal to 1 dm cube. The first conversion. And next, see, 1 liter will be equal to 10 raised to 3 cm cube, centimeter cube, which is in turn equal to 10 to the power of 3 milliliter. And next, this 1 liter will be equal to 10 to the power of minus 3 meter cube. So these are the important conversions which you must know. Next, let us come to the laws of chemical combination. So there are 6 important laws of chemical combination. Let us discuss one by one. See, the first one, law of conservation of mass. So the name itself is saying mass is conserved in the reaction. That means how much amount of reactant you have taken, that is its mass, that must be equal to mass of the products formed. So you can simply remember it as mass of reactants is equal to mass of products. Understand? Next, definite proportion. Law of definite proportion actually says that if you take water, H2O, correct? So now you take this water from a sea. Just imagine. And there is water in beaker. And you might see water in a water bottle. Now if I ask you, what is the molecular formula of water in all these 3 cases? It will be H2O only, correct? So that is itself the definite proportion laws. The law says that the constituent of any compound will be same irrespective of where you find it. Okay, so that means there are 2 hydrogens. So therefore 2 into mass of hydrogen is to 1 into mass of oxygen. They have simple ratio. Mass ratio, remember it is the mass ratio, not 2:1 is not the ratio of number of atoms. Do not confuse it with the number of atoms. Next is multiple proportion. So now see, I have taken here carbon monoxide and carbon dioxide. So clearly see, here you can find only 2 elements, that is carbon and oxygen. but with different ratio they are combining to give a different compound, correct? So here mass of carbon is to mass of oxygen in carbon monoxide, but in carbon dioxide it is mass of carbon is to 2 into mass of oxygen. Are you understanding? So these two are in its simple ratio or multiple of this simple ratio. Understood? That is the law of multiple proportion. Next, let us come to the law of reciprocal proportion. Just imagine you have A, B and C elements. Okay. So now AB combines to form AB, B combines with form BC, C combines with A to form CA. Now I take the mass ratio of all these three, it will be mass of A is to mass of B, mass of B is to mass of C, mass of C is to mass of A. And all these ratio will be same or simple multiple of each other. That is what your reciprocal proportion says. Next is your Gay-Lussac's law. That is for gases volume actually. So the Gay-Lussac's law says that you find a reaction, okay? So let's say N2 plus 3H2 give rise to 2NH3. Formation of ammonia is there. Clear? Now I have balanced the equation, and from this balanced equation I can say that 1 mole of nitrogen combines with 3 mole of hydrogen to give 2 moles of ammonia, right? He said that this mole is directly proportional to volume. Okay, so it means 1 volume of nitrogen combines with 3 volume of hydrogen and 2 volume of to give 2 volume of ammonia. Now this volume of the products and reactants are in simple ratio. That's all. And you must see that it should be applicable only for gases, not for everything. And at same temperature and pressure. So all the gases must be at same temperature and pressure. Then only you can apply this particular law. Next, let us come. That is Avogadro's law. Avogadro's law says that you have X gas. Here also I am mentioning it is also for only gases, and Y gas. Okay, now I have taken X gas 10 ml and Y gas 10 ml, and I have maintained same temperature and pressure. What all I did? I have taken 2 gases to equal volume of 2 different gases and maintain same temperature and condition. At this point, you might expect that number of X gas molecule will be equal to number of Y gas molecules. So that is your Avogadro's law. At same temperature and pressure, 2 different gases of equal volume will have same number of molecules. This came from again your Gay-Lussac's law, which already told you that volume is directly proportional to number of moles. Understood? So these are the important laws in which last 2 laws, that is Gay-Lussac's law and Avogadro's law, are applicable only for gases at same temperature and pressure. Now let us move further. That is your Dalton's atomic theory. Atoms were discovered, but what is the nature of atom? It is explained through Dalton's atomic theory. So the first thing he said is matter is composed of small indivisible particles called atoms. There is matter. Matter has small particles that are atoms, and these particles are indivisible. You cannot divide it. Next, atoms of same elements have same properties and mass. If you take same element and in that same element you note down two different atoms, then both atoms will have same properties. Next is atoms of different elements have different properties and mass. So now if you take atom of silver and atom of gold, both have different properties and both have different masses. The next is compounds are formed when atoms of different elements combine in fixed ratio. So when you can expect carbon dioxide to form? When carbon and oxygen atoms combine in different ratio. Next is atoms can neither be created nor destroyed. Same like energy, you cannot create atom and you cannot destroy even an atom. You cannot create energy and you cannot destroy the energy also. You cannot create a mass and you cannot destroy the mass. Simple law of nature. Chemical reaction involve reorganization. So see, in the chemical reaction, you might expect there is different product is formed. How it is formed if atom is not created nor destroyed? The only possibility is that atoms in any matter you can see there are atoms and there is a proper alignment of atoms will be there. Correct? This alignment may change. That is reorganization of atoms may occur which can give you a completely different product. And the limitations are could not explain law of gaseous volume, that is we studied Gay-Lussac's law. That law cannot be explained according to this theory. Could not provide reason for combining atoms. Okay, atoms combine and reorganize. That I agree. But why? It couldn't explain that figure. It could not explain why atoms of different elements have different mass and size and valency. He said, yes, atoms of different elements have different properties. But why? He couldn't explain. That are its limitations, most important limitations by the way. Now, let us understand what is mole. Okay, it is a very interesting thing. So see, for everything you calculate, there is a reference. So if I tell you that what is the mass of this remote? You will say, ma'am, it is 100 grams. Then what is the reference? You can say 100, it is a number, into 1 gram. So this 1 gram is a reference. Like this also, they wanted some reference for your elements or compounds. So what they did is, scientists, they took carbon-12 isotope, particularly carbon-12 isotope they took, and only one atom, okay, one atom of carbon-12 isotope, and under mass spectroscopy, which will, if you take a master's, then you can study about spectroscopy. Otherwise, in simple words, it is a process or a device used to calculate mass of an atom. Okay, so by this mass spectroscopy, they calculated mass of one carbon-12 isotope, and that came around 1.99 into 10 raised to minus 23 gram. Just wait. Now what they did in the next step is, they took a bowl. In this bowl, they added 12 gram of carbon-12 isotope. How many? 12 gram of this same carbon-12 isotope. Now they wanted to calculate how many atoms are present in this. In this 12 gram of carbon-12 isotope, how many number of atoms present in this? So how you can do? If I tell you, one apple is of 2 gram, okay, and the 5 apples together will be how many grams? If one apple is 2 gram, 5 into 2, correct? 5 into 2 will give rise to 10. That is the final mass, correct? So now from that, you can 10 divided by 5 will give you 2 gram. That is mass of one your apple. Similarly, here also you will be doing, that is total mass. You will take a total mass and you will divide by mass of one carbon-12 isotope. That is 12 divided by 1.99 into 10 raised to minus 23 gram. And it came around 6.023 into 10 raised to 23 atom, which is in turn called as 1 mole Avogadro's number. Understood? This is your Avogadro's number. So what is the conclusion for this is, whenever you take any gas, 1 mole of gas, how many atoms are present in that? Avogadro's number of atoms. That reference. And now, what is the reference for atomic mass? They wanted to calculate reference for mass also. That was for number. But for mass, what is the reference? Then, what they did is, they took 1 atom of carbon 12 isotope. 1 atom. And they divided this 1 atom into 12 parts. Okay. So, out of this 12 part, what is the mass of 1 part? They had to calculate. So, that is 1 by 12th mass of 1 carbon 12 isotope is used as a reference, and it is called as 1 AMU or 1 U unified mass or 1 Dalton. But what is the value of this 1 AMU? It's very easy, right? I already told you that what is the mass of 1 carbon 12 isotope? Just take it. 1 mass of carbon 12 isotope is 1.99 into 10 raised to minus 23 gram, which is equal to, divided by 12. It will give you 1.66 into 10 raised to minus 24 gram, which is approximately equal to your mass of proton. So that means, what exactly you are dividing to get your atomic mass? You are dividing the mass of a proton. That number is actually giving you how many number of protons and neutrons present in there. Because mass of proton is approximately equal to mass of neutron. Correct? That's the thinking of the scientist. Understood? Right? So 1 AMU will be equal to mass of proton or mass of neutron, that is 1.66 into 10 raised to minus 24 gram. Okay, you got till now. So I will tell you how and where we will be using 1 by 12th mass of 1 carbon 12 isotope. For now, let us understand now molar volume. What is molar volume actually? So see, I have taken 1 mole of oxygen gas. Till now I told you already, 1 mole of any gas will be equal to Avogadro's number. So how many atoms are present? Avogadro's number of atoms are present, that is 6.023 into 10 raised to 23. Correct? Now, what I will do is, I will take a container and I will take a movable piston, so it can move itself. And this container is at STP condition. What do you mean by STP? Standard temperature and pressure. Pressure must be 1 atmosphere or 1 bar and temperature must be 273 Kelvin. And at this condition, what I will do is, I will add this 1 mole of oxygen gas into the container. As I add, the piston will move as the volume is increasing. Correct? And the volume which is occupied, this 1 mole of gas, is called your molar volume. And it will be equal to 22.4 liter. Understood? 1 mole of any gas at STP will occupy how much volume? 22.4 liters. Okay. Now, molar mass. Let us come to the molar mass. I have 1 mole of oxygen atom. 1 mole of any gas, any atom, it will be equal to Avogadro's number. Correct? So 1 mole of oxygen atom, Avogadro's number. 1 mole of hydrogen atom, Avogadro's number. 1 mole of nitrogen atom, Avogadro's number. Clear? And this mass of, understand the point, mass of 6.022 into 10 raised to 23 atoms together is your molar mass. Understood? It is not mass of 1 atom. It is a mass of 6.022 into 10 raised to 23 atoms. Okay. Okay. So now let us revise which are the most important topics which you have to add in your notes. Till now what I have explained, it is for your understanding. Now let us come to the notes part which you have to remember in examination. So the first one is your mole definition. From mole definition, what we get the formula. That is, N is the number of moles. It will be equal to your given mass divided by molecular mass. You have to take given mass and you have to divide it by molecular mass. You will get number of moles. If you were given number of atoms or molecules, then given number of atoms or molecules divided by Avogadro's number, then you will get number of moles. And if it is gas, that too in STP condition, then given volume divided by 22.4 liter will give you number of moles. Remember, it is only for gases. Only gases, that too at STP. Standard temperature and pressure must be given in the question. Then only you can apply this formula. Okay. So this is the first formula which you have to remember. The next thing which you have to remember is very important. In examination, you might find 1 gram oxygen only. 1 gram oxygen atom is given. 1 gram oxygen atom. What does actually mean? Is the mass is 1 gram only? No. This actually means the mass of 6.022 into 10 raised to 23 atoms of oxygen. So 1 gram of anything is equal to your molar mass here. Understood? So you have to find difference between 1 gram atom of anything. Okay? Or the mass of this is, mass of oxygen atom is 2 gram. Then it is a different. Next, third important point is, in examination you will be given any molecule, let's say AXBY, and the moles is N moles. N moles of AXBY molecule. They might ask you, that is, number of AXBY molecule. How many molecule are there? Then how you will do? How many number? So given number you have to calculate. That will be equal to number of moles into Na. That is Avogadro's number. If you are asked number of A atoms, only A atoms they are asking. Then how you will do? You will do, that is, N into before number, let us go for total number of atoms. Number of atoms, that is total number of atoms I am telling. Till now calculated molecule, okay. But when come to the atom, see, in 1 mole of AXBY, how many, in 1 molecule of AXBY, how many A atom are present? X. How many B atoms are present? Y. Correct? So simply you have to do number of moles into Na, which will give you number of molecules. And you simply multiply it with by total atom present, X plus Y. It will give you total number of atoms. If they ask only A atom, A atoms only, how many A atoms are there? Then simply number of molecule you will calculate, and then you will multiply how many atoms of A is present in 1 molecule of AXBY, that is X. Number of B atoms, that will be equal to number of molecules into number of B atoms in 1 molecule of AXBY. Correct? If they ask number of electrons in AXBY molecule both, total number of electrons they are asking, then what you will be doing? You will be taking N number of moles of molecule, and per atom you will be calculating the electrons. Let's say A atom has electrons of N, let's say electrons number EX I will take, okay? Electron number. Electrons of A into X plus electrons of B, that is Y, into Y. This will give you the total number of electrons. Electrons present in A and multiply with number of A atoms. Electrons present in B multiplied by number of B atoms present in one molecule. Understood? The next is, they might give you an ion. They might give n moles of A plus or minus X ion they might give. So let us take two cases. That is n moles of A plus X cation and anion I will take. What do I mean by cation? What does this represent? It represents that it has lost X number of electrons. So how many number of electrons is there? Number of electrons. How we will calculate? Number of atoms first, number of moles into Avogadro's number. Then what you will do? You will multiply it with by electron of A. What does this mean? It means it has lost this much of electron. Therefore, minus X. And here, number of at A minus X ion multiplied with by electrons totally present, minus means it has taken, therefore plus X. Understood? So this is the basic first thing which you have to remember. You have to write down this in your notes only. Next, let us go towards the mass. In case of mass, see, if you have an atom, single atom, you can have same atom combination. You can have two different atoms combined. So single atom, atom. Two atoms, same atoms combining, molecule. Two different atoms combined, it may be ionic compounds or other molecule it can be. Okay. So it is your atomic mass. It may be your molecular mass. And if the ions are combined, then it is your formula mass. So let us understand one by one. The first one is atomic mass. If you have atom, its mass is atomic mass. So there are three different ways to calculate atomic mass. So first one is your relative atomic mass, average atomic mass, gram atomic mass. So relative atomic mass means in relation to something. Now the concept of AMU comes here. So what you will be doing is mass of atom you will take. It is calculated by spectroscopy, remember. This mass of atom you will be dividing it by 1 by 12th mass of carbon 12 isotope. That is 1 EMU. We will divide it by 1 EMU to get relative atomic mass. Average atomic mass is used in case if you have given isotopes. So what you will be doing? You will be taking your two isotopes, let's say A isotope and B isotope. So mass of first isotope and its percentage composition plus mass of second isotope and its percentage composition divided by total percentage composition, which will be usually 100% always. So this is called as average atomic mass. Gram atomic mass means just the mass of 1 mole of atom. Mass of 1 mole of atom is nothing but your gram atomic mass, which is expressed in grams. That is your gram atomic mass. And when I come to molecular mass, you will be expected to remember these two. That is relative molecular formula, molecular mass, relative molecular mass, gram molecular mass. Relative molecular mass similar to relative atomic mass, that is mass of molecule divided by 1 by 12th mass of carbon 12 isotope. This is your relative atomic mass. Gram atomic mass, mass of 1 mole of molecule expressed in grams. You just express it in grams. Here, mass of 1 molecule divided by 1 by 12 mass of carbon 12 isotope. But here, it is mass of 1 mole of molecule, that is 6.022 into 10 raised to 23 number of molecules. Next, for ionic compound mass, so you will be using formula mass. So in this formula mass, what you will be doing, let us take an ionic compound AXBY. So the formula mass, you can expect it as mass of A multiplied by X plus mass of B multiplied by Y. This will be atomic mass. Remember, atomic mass of A multiplied by X plus atomic mass of B multiplied by Y. This will give you a formula mass. So these are the basic formulas. But there are other formulas which you can expect in case of miscellaneous questions. For atomic mass, see, the important one or this one. Clearly specific heat is given. Then atomic mass can be written as 6.2 divided by your specific heat. If specific heat is given. If molecular mass is given, from that you have to get your atomic mass by atomicity. Then what you will do? Atomic mass will be equal to molecular mass divided by atomicity. Suppose oxygen molecule is given O2 and they will ask you what is the atomic mass of oxygen. Then what you might expect? You will take molecular mass and divide. To get oxygen, 2 oxygen must be combining to give O2. So atomicity will be 2. Molecular mass divided by 2 you will be taking. Understood? Next, for molecular mass, the miscellaneous question might you expect from this formula, that is vapor density. So here your molecular mass will be equal to 2 into vapor density. That one you can expect. And next is your rate of diffusion. So if the rate of diffusion is given R1 divided by R2 of 2 gases, so that will be equal to square root of M2 divided by M1. That is molecular mass of first gas divided by molecular mass of second gas. Okay, so this is given in your gaseous state, but that chapter has been removed. But still you might be expected to solve questions based on this particular formula. Now let us move towards the equivalent mass concept. So this equivalent mass formula is, carefully see. So if atom is given, then you will write atomic mass on the numerator. If molecule is given, you will write molecular mass. If ionic compound is given, you will write formula mass. That will be your numerator based on what type of compound you are given. Okay. Divided by, that is also based on different things which you can see in your examination. So first, if there is neutral atom, you might take valency here. Or if it is an oxidizing or reducing agent, you might expect to take change in oxidation number or a number of electron transfer. How many electrons are being transferred in case of oxidizing and reducing agent? If you were given acid, you might take basicity. If you are given base, you might take acidity. So this is how you will calculate your equivalent mass. Understood? Let's see. I will give example. for valency, you have your hydrogen atom. Okay. For hydrogen atom I'm saying, molecule is different, atom is different. For hydrogen atom, they expect you to calculate equivalent mass. What is the mass of atomic mass of hydrogen atom? 1. Correct. What is the valency? That is how many electrons it has to gain to complete its octet to become helium. Another 1, right? So it will be 1 divided by 1. So therefore, equivalent mass of hydrogen is equal to 1, hydrogen atom. And for molecule also it will be 1 because it contains 2 atoms. Now valency will be equal to 2, right? Both atoms need 1 electron. 2. What is the mass of molecule hydrogen? Now there are 2 hydrogen atoms, 2 grams, correct? Now, for change in oxidation number and electron transfer, how you will do? You have M metal atom. Okay. Now what is doing? It is undergoing reduction. So it gives M minus N. So how many electrons are being transferred? N electrons. So it will be atomic mass of M divided by N. This will give you an equivalent weight. Then in case of basicity, you have acid, that is HCl. How many replaceable hydrogen are present which can give rise to H plus ion? Only 1. Correct. So it will be mass of HCl, molecular mass of HCl divided by your 1. Only 1 replaceable hydrogen is there. In case of H2SO4, there are 2 replaceable hydrogen. So mass of H2SO4, the molecular mass divided by 2. Understood? Next, in case of bases, you have NaOH. How many replaceable of OH? 1. Correct? And in case of calcium hydroxide, 2 replaceable OH minus. There are 2 OH minus. Correct? Therefore, its valency factor will be 2. Understood? Okay. Now we can move towards a percentage composition. It is also important. Now see, I have here H2O, 2 hydrogen and 1 oxygen atom. It is formula is H2O. What is the molar mass? It will be equal to 2 into mass of 1 atom of hydrogen plus 1 into mass of oxygen, which will be equal to 2 into 1, 1 into 16. Total 18 gram. We got molar mass 18 gram, correct? But if you were asked mass contribution of hydrogen atom to total mass of 18 gram, out of this 18 gram, how much mass is contributed by hydrogen? That is your percentage composition of hydrogen in H2O. How you will calculate? You will simply say, what is the total mass of hydrogen present here? That is 2 into 1. Okay? So mass of total hydrogen in 1 mole of H2O divided by what is the total mass, molar mass, right? Molar mass of H2O. Then you will get fraction. But it is a percentage composition. So just convert this fraction into percentage by multiplying it by 100. Similarly, you can do for oxygen also, correct? So it will be 16 divided by 18 into 100. That's all. What is your percentage composition is all about. Next, let us come towards empirical and molecular formula. How you, what is empirical and molecular formula? Let us see. You have your ethane, C2H6. Empirical formula is means simplest whole number ratio of various atoms present in a compound. So there, how many atoms are present? Different types of atom, carbon and hydrogen. What will be the simple whole number ratio? So ratio is 2:6 here, correct? But it can be in simpler form, correct? 2 1s are 2 3s are. So 1:3 is your simple whole number ratio which cannot be further divided. So that composition will be your empirical formula. That is C1H3. Whereas molecular formula represent exact number of different atom present. How many exact number is present? C2. 2 carbon is present. So therefore C2H6 will be your molecular formula. Understood? So let's come to the structure of problem and solution. So in problem you will be given mass. Molecular mass will be given. Remember. And percentage composition of each element will be given. So see here. So element you will write. Let's say you have A, B, C. Different elements is given. Next, at next column, percentage of each element which is given. Contribution will be given to you. That contribution you will be writing. Let's say it is A, B and C given to you. And next column you will find out atomic ratio. That is, you will take A and you divide it by atomic mass of A. B divide by atomic mass of B. C divide by atomic mass of C. And you will get one ratio. And then you will take the least ratio. Let's say this one has a least ratio. That is least number it is having. Okay. So what you will do, you will divide it by every other number. So see here, if it comes as E, it comes as F, it comes as G. Now it is your least number out of all these three. Then how you will get the least ratio? You will take E divided by F, F divided by F, G divided by F. Like this you will get the least ratio. And finally you will get some value X, Y and Z. How you will write empirical formula now? From this, empirical formula will be elements A, B and C. And you will add the coefficient X, Y and Z. This is your empirical formula. For molecular formula, what you have to do? For molecular formula, you will calculate mass of this. Calculate mass. And simply here you should calculate value of N. That will be equal to molecular mass, which will be given in the question, divided by empirical formula mass. That will give you value of N. Now what you have to do, final step, you take your empirical formula, that is AX, BY, CZ and multiply it with Y, your N value. This will give you a molecular formula finally. Understood? Every problem will have the same structure. Nothing is different. Now understand the stoichiometry. So this stoichiometry, it is nothing but calculation of quantities of reactant and product involved in chemical reaction. That is how much A is there and how much B is there, which is reactive. Okay. So there are two methods. First is mole concept. You can use the mole concept to find the amount, or you can use POAC method, principle of atom conservation, which I will explain. Okay. See here, mole concept is nothing but you have to balance the equation. Given equation it will be there and you will balance it. First you will take metal, you will balance, then you will balance your carbon, and then you will balance your hydrogen, and then you will balance your oxygen atom. POAC method, balancing is not required. Simply you can calculate the mass. How? I will tell you. So principle of atom conservation, I told you, right? POAC means principle of atom conservation. So it is nothing but, in reaction we already knew, right? Atoms can neither be created nor destroyed. If atoms are not created and not destroyed, it must be conserved. Therefore, number of atoms of reactants, total number of atoms of reactants must be equal to number of atoms of products, because atoms are conserved. Products are formed by reorganization of the atoms, not by destroying. It must be same. Correct? So see here, if you have CH4 methane and it is combining with oxygen to give CO2 and H2O, now I will take CH4. Okay, I will talk with respect to this. This CH4, hydrogen is there, correct? And hydrogen is there in the water also, in product side. So I can write number of carbon atom in 1 mole of CH4. So not hydrogen, It might be of, I'm talking about CO2. Okay. So see here, how many carbon atoms are present in CH4? That must carbon atom present in CO2 also, because carbon atoms cannot be destroyed or not created. Correct? So number of carbon atoms in 1 mole of CH4 must be equal to number of carbon atom present in 1 mole of CO2. Understood? So it will be equal to number of atoms, carbon atom in CH4. 1 molecule of CH4 contains 1 carbon atom, and you will multiply it by number of moles given, is equal to number of carbon atom in CO2. How many carbon atom are present? 1 carbon atom, multiplied by number of moles of CO2. From this equation, you can easily calculate a mass of carbon. Understood? Okay. Next is the simple formula which you have to write in your notes to understand. If only one compound in product side is given, then what you will do? Number of conserved atom in reactant compound, you will multiply by moles of reactant compound containing conserved atom, is equal to number of conserved atom in product side of compound multiplied by moles of product compound conserved atom. That is, A plus B give rise to your AB, or you can say AC plus CD give rise to AD plus C2. Like this. So see here, if you take AC and AD, number of A atoms will be equal to number of A atoms in AD. So simply number of atoms conserved in reactant compound, that is A, which is equal to only 1 is there. Number of moles of AC you have to take here. Number of conserved atom in product side of compound. So here A, which is also equal to 1, and number of moles of AD you must take. Understood? Is it clear? Okay, let's. If the 2 compounds in the product side is given, then what you have to do? Number of conserved atom in reactant compound, moles of reactant compound containing the conserved atom. Then at the opposite side you will take number of conserved atom in first product side of the compound, that is, see here, AC plus CD give rise to AD plus C square. Let's take the opposite side of this. Much better. Okay. So this you are getting. Understood? 2C. Let us take. This you are getting a reaction. Now, see here. C is present in only one reactant. But in product side, C is present in 2 products. So what you will do? Number of conserved atom in reactant compound. How many atoms are present in reactant compound? C atoms were 2, correct? So we will take 2 atoms were there. Multiplied by number of moles of the conserved atom. Number of moles of C2 you have to take. Understood? C2. And it will be equal to, how many C atom is present in AC? 1. That is, C is equal to 1 is there. And what is the number of moles of AC? Which will be given in question, you will multiply. Plus, number of conserved atom in second product side, CD. How many C atom are present? Only 1 atom per molecule. Multiply by number of moles of C and D. That will give you the equation. And out of this equation, what you will do? You will simply, given mass divided by molecular mass, you can convert this number of moles. And from there you can find given mass. And now see, if the sequential reaction is given. Clearly see, this is a sequential reaction. After one step and after there is another step. So in this sequential reaction, the first and final equation you have to consider to see which atom is conserved. So see, in the first step, reactant side, which are the atoms present here? Zinc, sulfur and oxygen. Okay. Now, come to the last step of product. Which are the atoms which are conserved? That means zinc present here. Zinc is also present here. Sulfur is present here. Sulfur is also present here. Oxygen is present here and oxygen is also present here. So first step you find out, that is zinc, sulfur and oxygen, which are common in reactant. First step reactant and last step product side. Second step what you will do, remove atom which is added again in middle step. So see, in middle step, which is the new reactant added. So first step occurred, ZNO formed and 2SO2 is formed. And the formed ZNO is used. So this is not new because it is already formed. And newly we are adding this H2SO4. This one is new. Correct? So now the atoms which are present in this new compound which is added, you remove it. First it was zinc, sulfur, oxygen. Now see, out of these three, which atom are present here in H2SO4? Sulfur and oxygen. So therefore sulfur and oxygen are not conserved. Only zinc is conserved. Understood? Zinc is conserved everywhere. Okay. Once you got which is conserved, the next step is how to apply POAC concept. So for this, what you have to do? You have to consider these two sides only when if 100% yield is given. See, number of zinc atom in ZNS. How many zinc atom are present in ZNS? Only one zinc atom, correct? 1. Number of ZNS you will take, which will be equal to what? You are taking zinc, right? Here it is zinc. Number of zinc atoms in zinc atom into number of moles of zinc. It will give you the required answer. If the yield is not 100%, let's say like this yield is given in examination. So it is a high level question, most miscellaneous questions which will be asked. So in this type of question, what you might do is clearly see here. In first case, when you react to it, you must get 100% of ZNO, but you are not getting as 80% yield is there. So now you have to calculate POAC for single step. So see, first I will take this one. Here zinc, correct? Number of zinc atom in ZNS, multiply it by number of moles of ZNS. Here, number of zinc atom in ZNO multiplied by number of moles of ZNO. From this, you will get 1 mole of zinc ZNS giving rise to 1 mole of zinc atom. Correct? What you have to do? It is 80%. Correct? Yield is 80%. So you will not get 1 mole of zinc here. Instead, you will get, the answer will be 1 into 80 divided by 100 moles. 1 into 80 divided by 100. You will simply multiply with the yield. That's all. Fraction of yield. That is 80 divided by 100. Multiply it. In the next step, simple. What you will do here? See. Here you got 1 into 80 divided by 100 zinc. Understood? Then this reaction is giving rise to this ZnSO4 and it is 100% yield. So what you might expect? Number of zinc atom in ZnO multiplied by number of ZnO, number of zinc atom in ZnSO4 multiplied by ZnSO4. So how much? Here it was 1 into 80 divided by 100 moles of ZnO. So it will give 1 into 80 divided by 100 mole of ZnO. Why? Because it was 100% yield. But again it was 80% yield right here. See, 80% yield. So how much I have ZnSO4 here? 1 into 80 divided by 100. So similarly, it should have been given you 1 divided by 80 mole of Zn atom. But the yield is 80%. So what you will do? With given answer, multiply by yield again. So it will be 1 into 80 divided by 100, the same one, and multiply by yield given. That's how you have to approach the problem. So POAC method is very useful. You no need to balance out the equation at all. Now let us come to the limiting reagent concept. It is also very useful. It will be asked in an examination. So see here, what will happen in a reaction? One reactant might be excess, one reactant might be lesser. Understood? The one reactant which is lesser, it will be consumed completely. Are you understanding my concept? Which is less, that will be consumed completely, and the reactant which is consumed completely is your limiting reagent. That's all. And the reactant which is present even after completion of reaction, that will be your excess reagent. So I will tell you a simple example, then you will understand. See here, nitrogen combines with hydrogen to give 2 moles of NH3. Now what I have done here, I have balanced the equation to tell you. You can also use POIC concept. Now I have balanced. See, clearly see here. 1 mole of nitrogen require 3 mole of hydrogen to give 2 mole of ammonia. It is according to the balanced equation. But in examination, it is given that you are mixing 2 moles of nitrogen and 3 moles of hydrogen. Now tell me which is the limiting reagent. So what you have to do, the approach will be very simple. See here, 1 mole of nitrogen will require how many moles of hydrogen? 3 moles of hydrogen. Correct? Then 2 moles of nitrogen will require how many moles of hydrogen? Cross multiplied, you will get x into 1 is equal to 2 into 3. How much? 6 moles. 6 moles of hydrogen is required for 1 mole of nitrogen, 2 moles of nitrogen. But how much we have? Only 3 moles we have. We have less. Correct? Do opposite now. For other one. See, here, 1 mole of nitrogen require 3 mole of hydrogen. Correct? Oh, 3 mole of hydrogen. Then 3 mole of hydrogen will require how much mole of nitrogen to give complete reaction? Cross multiplied, y into 3 will be equal to 1 into 3. So therefore y is equal to 1. Understanding? 3 moles of nitrogen will require only 1 mole of nitrogen. So which is excess now? 1 mole is only utilized. 2 moles are present. We require only 1 mole. So this is in excess now, and the one which is in less is your limiting reagent. Ma'am, why limiting reagent is important now? How many moles of ammonia you will get? That is decided by your limiting reagent only. So now carefully see here. It will give you how many exactly moles of product you are getting. If you are using 3 moles of hydrogen, it is giving 2 moles of ammonia. But now, if you use 3 moles of hydrogen again, how much it might give? Let's take Z. So it will be 2 moles of ammonia. Understood? So that will decide the product. Now if there are fools here, if they take nitrogen without doing the limiting reagent concept, what the answer they will get? See here, 1 mole of nitrogen will give 2 moles of ammonia. Then 2 moles of nitrogen will give how much ammonia? They will write, ma'am, 4 moles of ammonia, which is wrong because they have not used limiting reagent concept here. Understood? Okay. Now let us come to the concentration term. First concentration term is molarity. So in this molarity, what they are doing? They are trying to tell you how much amount of solute and solvent are present. Simple. Composition of a mixture. So see, it says number of moles of solute dissolved in 1 liter of solution. So you have one solution here. It is 1 liter. In this 1 liter of solution, how much moles of solute is there? So it will be number of moles of solute divided by volume of solution in a liters, it must be there. When come to molality, It says, talks about not liter, it talks about 1 kg. If you have 1 kg of solvent, then how many amount of solute you have added? Small m is equal to number of moles of solute divided by mass of solvent in what? In kg. It must be always in kg. Okay. Normality. So it is not talking in terms of moles. Now it is talking in terms of gram equivalents, dear. So it is number of gram equivalent divided by volume of solution in liters. So gram equivalent is nothing but number of gram equivalent will be equal to your given mass divided by equivalent mass. Understood? Whereas number of moles is equal to given mass divided by molecular mass. Right? So this is a gram equivalent. Next, mole fraction. It is talking about fraction. When you take a circle here, the circle is whole, a solution or a compound. Now you divide the composition. Half, half. So what is part? This part? Half of the circle. What is this part? Half of the circle. Similarly, in a solution, if I were to tell you how much part of solute is there, how much part of solvent is there, that will give you a mole fraction. So mole fraction of solute will be equal to number of moles of solute actually present divided by total moles of solution, that is number of moles of solute into plus number of moles of solvent. Whereas mole fraction of solvent will be equal to number of moles of solvent divided by number of moles of solute plus number of moles of solvent. Now see here, if I tell you add both the fraction, what you will get? Half plus half is equal to 1. Similarly here also, if you add both the fractions, that is mole fraction of solute and solvent, it will be equal to 1. Understood? So that is very, very important for you all. So next one is your mass percentage. So how much mass? I told you percentage composition in terms of mass, right? That is also atomic mass I told you. But here mass percentage similar to that only. How much mass of solute is there? Mass of solute with respect to your mass of solution into 100. That's all. That will give you mass percentage. Remember, both numerator and denominator must have same unit. If the numerator is in kg, denominator must be in kg. If numerator is in gram, denominator must also be in gram. Next, volume percentage, similar. Instead of mass, we are taking volume. So, volume of solute divided by volume of solution into 100. What is mass by volume percentage? Similar. Mass. That means numerator is mass of solute. By volume, that is denominator is volume of solution in 100. Volume strength, you will not multiply by 100 simply. So you will just take your mass of solute divided by volume of solution. But in this case, it must be in liters. Okay. Parts per million. Similar to percentage. Percent. See, per what? Cent. That is 10. 100, right? 10 times to 2. But here per what? Million. Simple. So, parts of solute, it may be mass or anything, divided by total parts of solution. It might be total mass. And you will multiply by million. That is 10 raised to 6. That's all. So what is this mass percentage tell you? See, if you are given, carefully here, if you were given 32 mass by mass percentage of aqueous NaOH, what does this say? It says that you have 32 gram of NaOH in what? Per 100 gram, right? In 100 gram of solution. From here, carefully see. What is the mass of water? Aqueous. Can I calculate? Yes, you can calculate. That is 100 minus 32 will give you mass of solvent. That is your water. Next, last one is your mixture concept. Let us understand. So see, in mixture, you can add, like you can take acid and you can add with water. Or you can take base and add water. This is called your dilution. That is, acid is diluted. That means in acid you are adding water. Or base is diluted. That means in base you are adding water. Dilution. The next case might be acid and base. You are mixing acid plus base, not water. So what may happen? Neutralization may occur. That means pH will come to 7. It not be acidic, it will not be basic. That can happen. Otherwise, no neutralization may happen. In that case, how will you calculate final concentration? That is the question. So in case of your dilution, see, acid plus water if you have added, then you must be using formula M1V1 is equal to M2V2. Understood? So this will be initial molarity concentration of acid and volume of acid you have taken. This will be final concentration of acid plus water mixture and volume of your mixture. Understood? Next, let us come to the neutralization. In neutralization, you will use normality. N1V1 is equal to N2V2. This may be of acid and this may be of base. Concentration of acid multiplied by volume of acid you have taken is equal to concentration of base into volume of base you have taken. If no neutralization has occurred, then what you will do? You will take here N1, N3, V3 will be equal to your N1V1 plus N2V2. That's all. Oh, hope not plus. It will be minus, as acid and base you have taken. Minus. Understood? Or it can be written as N1V1 plus N2V2 and V3 how you can write? Total volume. It will be V1 plus V2. Understood everyone? So that's how you will calculate final concentration. There is another thing. If acid plus acid is given, acid is added to another acid or base is added with another base, how you will calculate final concentration? So if there is acid and acid, instead of writing plus minus, you will add here plus, that's all. So here N3 will be equal to N1V1 plus N2V2 divided by V1 plus V2. Here also N3 is equal to N1V1 plus N2V2 divided by V1 plus V2. That will give you a final normality. That is all what you have to understand in this particular chapter. So I hope you understood the most important topics in the mole concept. As it is synopsis, we cannot go much deeper into the one single topic, but there is a possibility of only and only if you solve the home assignment questions. So stay tuned. Thank you.